Solve a problem using implicit differentiation. And here we have the equation xy squared minus 2y plus 4y cubed equals 6. And this equation is going to be in the context of this problem. If y is a differentiable function of x, then the slope of the curve of xy squared minus 2y plus 4y cubed equals 6, the point where y equals 1 is, and we have these four possibilities as answers. What we're going to look for is the slope of the curve, and to do that, we have the slope is the change in y divided by change in x. Sometimes you see this written as delta y over delta x. And in calculus, we more often see this dy dx, which is the notation we're going to use for this problem. And so we're going to see at the point where y equals 1, what is going to be the rate of change in that function, y with respect to x. Now we're going to need to have, to solve this, a point. And a point is a coordinate pair. And we are already given the y coordinate, which is 1. We need to find that x coordinate. Well, to do that, we're going to use this equation, and I'm going to work this over the right. So x times, substituting 1 for y squared, minus 2 times 1 for y, plus 4 times 1 for y cubed is equal to 6. And now simplifying, 1 squared times x is x. We left side have x minus 2 plus 4 is equal to 6. And then negative 2 plus 4 is going to be plus 2. So we have x plus 2 is equal to 6. And then solving finally for x, we have x is equal to 4. So this 4 is going to go over here to our x coordinate. Okay, and that's it right here. And now we're going to get to implicitly differentiating this equation. For the first term, xy squared, we're going to take x times the derivative of y squared, which is going to be 2y, and then that's going to be dy dx. And then we're going to take the derivative, we're going to take y squared times the derivative of x. So we say plus y squared, and the derivative of x is going to be dx dx. I hope you can see where that's going. And next, the derivative of negative 2y is going to be negative 2 dy dx. And then the last term on the left, we have the derivative of 4y cubed is going to be 12 y squared dy dx. And the right side, our derivative of the constant 6 is 0. So now I'm going to do a little rewrite here on the left. We have 2xy dy dx. And then we have this on the second term, dx over dx cancel each other. So we have plus y squared. And then we're going to have minus 2 dy dx. And then plus 12 y squared dy dx is equal to 0. Now we're just going to leave everything with a dy dx on the left, and then with everything without a dy dx is going to go to the right. So this only thing we have without a dy dx is this y squared. So we're going to subtract y squared from both sides of the equation. So we have remaining 2xy dy dx. And then we have minus 2 dy dx plus 12y squared dy dx is equal to negative y squared. And now we have as a common factor for all three terms on the left, this dy dx. So I'm going to rewrite as dy dx times 2xy minus 2 plus 12y squared. Okay, and that's going to be equal to negative y squared. Now, solving this equation for dy dx, we're going to divide both sides of the equation by 2xy minus 2 plus 12y squared. And doing the same thing on the right side, 2xy minus 2 plus 12 y squared. And then we have a cancellation on the left, so we're left with simply dy dx is equal to negative y squared over 2xy minus 2 plus 12y squared. Now we're going to substitute in for the point 4 comma 1. So what I'm going to do is write that as dy dx I'm going to put here in parentheses at 4 comma 1 is equal to, on the top, negative 1 squared, and in the denominator we have 2 times 4 times 1, and then we have minus 2 plus 12 times 1 squared. Okay, and I'm going to go to the right here. Dy dx is equal to negative 1 in the numerator. In the denominator, we have 2 times 4 times 1, which is 8. And then we have minus 2 and plus 12. And this is going to simplify to negative 1 over 8 minus 2 is 6 plus 12 is 18. So we have negative 1/18. And so that's going to be answer choice A. So this is a nice little problem to work out. I went ahead and also graphed this, and I didn't have any idea really what this looked like. I know it's going to be some kind of curve. But this is what it looks like. At the point 1 comma 4, which I'm pointing to right now with that little finger, that slope, the instantaneous rate of change at that point, with respect dy dx, is going to be negative 1/18. So anyway, this I thought was a nice little problem. Good luck, and thanks for viewing.